This video is going to cover what the scientific method is and why we use it in science. So science is a general term that we use when we're talking about the different methods that we use to study the natural world around us. So in science, we always use observations and investigations to gain more knowledge about the natural events that are occurring. So life science, like biology or microbiology, we're observing and investigating living things. In earth sciences, like geology and meteorology, we're looking at the Earth's crust, the rock formations, the planets, the weather. So we're observing and we're investigating those things. For physical science, we are observing and investigating matter and energy. So, no matter what science we're looking at, whether it be life science, earth science, or physical science, we can use the scientific method in order to investigate problems in any of those areas. So let's talk about what the scientific method is. In the graphic, you can see these are the steps of the scientific method. So, number 1, state the problem. From your problem, you're going to want to gather information about your problem. So that's step 2. Step 3, you form a hypothesis or an educated guess as to what you think the solution to the problem is. From there, you're going to go to step 4, which is testing your hypothesis. You're going to come up with some experiments or investigations where you can actually test your hypothesis. Step 5, you're going to analyze your data. Once you've analyzed your data, then you can draw conclusions. So you've got 2 ways you can go. Either your hypothesis is supported or it's not. So let's look at hypothesis being supported. So you've done all your experiment, you drew your conclusion, you have come to the conclusion that your hypothesis is correct. So then what you're going to want to do is repeat it. Any good experiment needs to be able to be repeated several times and still get the same results. If you don't get the same results each time that you do the experiment, then something is wrong and you have to go back and troubleshoot. Alright, so now let's look at the other route. So if your hypothesis is not supported, then you're going to want to come back up here and modify your hypothesis, come up with a new experiment, new data, new conclusion, and hopefully you'll be supported. And then you can go this route to retesting or repeating. So you can see that it's definitely a cycle, and it's always going to be a continuous process. So when you come up with your hypothesis, you have to have 3 things that are extremely important. The first thing is that your hypothesis needs to be testable. If you cannot test your hypothesis, then you can't come up with experiments. So let's look at, we've got a bad example would be aliens exist. This would be very hard to prove. A good example would be a plant that receives 1 hour of sunshine per day will outgrow a plant kept in the dark. This is something real that we can test. So the second thing that your hypothesis has to be is fact-based. It can't be an opinion. We can't test this example here. Blue is the best color. That's just an opinion. So we can't really test that. So your hypothesis has to be fact-based. And then last and probably most important is that it also has to be a complete sentence. It can't just be a number or a phrase, but it's got to be a complete sentence. Alright, so that's what your hypothesis needs to be. Okay, so this video isn't perfect, but some of my words got cut off. But anyway, so once your hypothesis has been proven true through many experiments, so that means that you and maybe other people have repeated the experiments and gotten the same answer, then your hypothesis becomes a theory. Alright, so your theory is the explanation of why things or events, they're based on many observations and investigations, and explains why something happens. So scientific law is when you can predict, or actually it's a statement about what will happen under certain conditions. So we know that it will happen every single time, and it can be proved mathematically. So an example of this would be the law of gravity. Okay, so we've gone through what a hypothesis needs to be in order to be valid. So let's talk about the experimenting stage. So there's different variables that are going to be in your experiment. And a variable is defined as anything that can be changed or varied, in your experiment. So there's many different kinds of variables. So if we look at the picture here, we've got weather conditions, that's a variable. We've got type of water on these plants, that's a variable. The amount of water is a variable. We've got the amount of light, so we've got low light intensity or high light intensity. What else here? We've got the growing season, the temperature of the water, and also the amount of plant growth. So these are all variables. So we can define the variables by different types. So the first type would be the independent variable. This is going to be the variable that you change or control to see how it's going to affect the other variables in the experiment. The dependent variable is going to be the variables that respond to the changes of the independent variable. A constant variable is going to be a variable that you do not change at all. And then the control is a standard that to which others can be compared. And yes, that's my cat. So often when you are looking at your data for these types of experiments, you're going to be labeling them. So a good way to remember which variables go on which axis is dry mix. Okay, so your dependent variable or the responding variable will always go on the y-axis. The manipulative variable, which is the variable you're manipulating, or the independent variable, is going to be on the x-axis. So that's just a quick way to remember what goes on which axis. Alright, so let's look at an experiment example and identify the different variables. So the example. So if I want to see how Miracle-Gro affects plant growth, I'm going to give it to 4 different plants. So the first plant's going to get half a spoonful per week. Second plant's going to get 1 spoonful. Third one's going to get 2 spoonfuls. And then the last one's going to get no Miracle-Gro at all. Alright, so and then I'm going to give them all the same amount of sun and water. So that's the setup. So let's look at the different variables. So the independent variable is going to be the Miracle-Gro, because I'm going to change it for each plant to see what the effect's going to be. The dependent variable is going to be the plant growth, because that is the variable that's going to respond to the Miracle-Gro. So it depends on how much Miracle-Gro I give the plant. The water and the sun are going to be constants, because all 4 plants are going to get the same amount of water and the same amount of sunlight. And then the control is going to be the plant where I put no Miracle-Gro at all. So I can compare the growth of the 3 other plants to the control.